Welcome to today's tutorial. We'll be going through semester test 2 2022. So let us begin. So let's see. Before we begin, I'm gonna download the necessary files that I'm gonna have to work with. So come on, download. Okay, so this is what we're gonna have to work with. So I'll download the init_large _large.txt, and then I'm also gonna download this main.cpp, and then I think that should be enough. Yeah, that should be all. Then I think I'll just use CodeLight today. So let's start. Let me create the project. So I'm gonna call it computer science 1B 2022. Okay. Let me do this. 2022 paper B memo. And then, yeah, I think that should be, let me see. I think I should just, should I use this one or should I use code blocks? Let me decide. New empty file. Okay, let me do this. Add a new file. Let me check if okay, we'll just use code blocks. I don't have I don't have to write everything from scratch. Like the header file, I don't want to have to write all of that from scratch. That will waste unnecessary time. So we're just gonna use code blocks. Yeah, I'll just use code blocks. So let's use code blocks. Okay, my code blocks still running. I don't know why it's so slow. Let me close it and open it again. Okay, there we go. Yeah, let's just use code blocks. So I'm gonna create a console application and I'm gonna call it computer science 1B 2022 paper B memo. Okay. And then there we go. Yeah, we have our project ready. So let's read. So stochasticity, the University of Johannesburg needs you to create a data structure called the UJ image. containing a dynamic two-dimensional array of structures representing pixels. So you're gonna have to create a data structure called UJImage. So remember data structures, the data structures that we have, that we've been working with. So with a data structure, I would say it's a type that you use to sort of like represent structured data, or to sort of like structure data representing a specific entity, or in this case, an object. So you can create a data structure to do that. So we have been working with so far we've been working with two types of data structures. Let me see. Okay, I'm sure you've worked with vectors and whatnot, but yeah, let's just focus on the two. So the two that we're going to focus on is the record structure and the classes. So what's the difference between the two? Let's just do quick revision. So the difference between the two is not that much. So let's say, for example, I wanted to create a data structure, basically a data type that represents some structure or some structured data, or however you want to put it. So the difference between the two is that with a class, it has two things. A class, you have both properties and behavior, or both data and functions, or both variables and functions. With the record structure, you only have variables. And then with a class, you have variables and functions. So variables and functions, um, I used uh, to represent some structure or some object. In our case, we're gonna call it an object. So we can represent a student object and put in the characteristics of a student. So for example, we can say we would want to store, for example, the student number. So student number, that's that's thingy. That's our variable, or that's our data. This would be our data, or we just call it variable, but usually use the term properties or data. Yeah, one of those terms. Then you can also define functions. So for example, a student can run, and we can have a can run function, and then it shouldn't modify or whatever. It should just check if the student can run. Maybe have a const there at the end. So as you can see, this is a function. So that's the nice thing about a class. You can have both data and behavior, or both variables and functions. So someone might ask, why would you want to do that? But if you think about it in a more deeper level, every object has these two these two things. It has properties, and it has a certain way that it can behave, right? So the way it can behave, we represent that as functions, and the way the features for that object, we're gonna call that data, or we're gonna store that in variables. So let's say I wanted to represent what can I represent? So let's say I wanted to represent, okay, let's just say, um, yeah, let's just continue student. So instead of can run, let me just say has passed. So that's a function, right? Has passed. So a student has the ability to pass or fail. pass or fail, or can run, or whatever example you want to make. So the one thing that I want you to take note of is the way we've concluded what our functions are and what is our data. So our data of variables, for variables, we look at nouns. We look at nouns in our question. And then for behavior or functions, we look for verbs, doing word. And this, for example, this doing words could be run, jump, eat, like simple terms. That's basically a class. So it's very important to have these two types. So with the record structure, you can only store variables. You can only represent data. The nice thing about it is that the type that I've defined, it's now called what? Student. So the name of the data type, or the name of the class, or the name of the structure, it comes after that keyword. So remember, I created struct, right? So let's say I want to create a data type to represent a coordinate. So what constitutes of a coordinate? It's the value x and y, right? So I can group that into, or I can group, or we can say, we can use the term structure. I can structure that data, right? What am I structuring? It's data. If you look at these variables, it's just data. I'm structuring, or I'm grouping data and then representing it under one data type, of which the name of that data type is going to be after the keyword of the feature that I'm using. Could be I'm creating a record structure, or it could be that I'm creating a class. So now I can create a type of coordinate. And then I say first coordinate, something like this. I can do that because now I've created a structure to represent my data. And this structure is very useful because I can put in data that represent that's supposed to be grouped to represent the specific thing. In this case, it's representing a specific coordinate. So I'm going to need to have x and y. And then when it comes to classes, a class is basically a record structure, but it's an advanced record structure. So you can view it in this way. This is like a TES, or a very old, or a Mitsubishi, or very old model, right? And then this is what we call a McLaren or a Ferrari. This one has, they can both get you to where you want. They can lead you to the same destination. The only difference is that with this one, it doesn't have certain features that this new model, or this McLaren, or this Ferrari has, right? You could try to mimic, but when you're trying to mimic, that means you have to pimp this. You have to upgrade this car in order for it to work the same way as the latest models. And when you have to pimp it, just know, what are you doing when you're pimping? You're doing extra work. So for example, with the record structure, you can put functions, but not necessarily functions, but function pointers. So you see, you have to work extremely hard to mimic something that this car can do. So that's the only main difference. So, and with a record structure, by default, everything is public. Everyone has access to it, which is very bad. It's bad because, for example, let's say I wanted to create a structure for a client. And then for this client, let's say this is a FNB client. I want not class struct. So I wanted to create a data structure. Basically, a data structure is basically you defining a new data type, or defining a data type that structures data, or that groups data to represent a specific thing. In our case, we want to group data or we want to group variables. Remember, data at the end of the day is just variables. We want to structure or group variables to represent an FNB client, so that when you create an FNB client, each FNB client has these features or has this data. So what could be the data? Could be account number, could be the PIN, could be what else? Their name, first name, and then last name. Can have all these features. Then we can also have the bank balance. We can also have that. But then you see what the problem is now. If you make everything public, that means it's public, right? You get what public means. For example, you can hail a taxi and get a taxi. Like a lot of people have access to that. Basically, everyone has access to that. So anyone can hail a taxi and get inside the taxi or the bus or the train. It's public. It's everyone has access to it. It's public. There's no restrictions at all. So you get to see you start to see the problem when I go to Google. This is me typing on the search bar to search, right? This is what I'm typing now. What is Elon Musk's banking details, right? I type that question on the search bar. Could be Chrome, Firefox, whatever browser you're using. So I ask Google, and then if Elon Musk happens to be an FNB client and they use the record structure to represent each FNB client, meaning that everything by default is public, then I wouldn't be, we couldn't, we wouldn't be, we couldn't call that hacking. I'm not hacking. I'm not doing anything. This information is um is accessible by the public. We are the public. So if it's public, that means everyone has access to this information. You see where the problem is now. That means I can get his account number and then get his PIN and then transfer myself a few billions, and then I'll be like, okay. And no one has the right to say anything, or no one has the right to complain because the information is public. And then if I also happen to be, after transferring that money, and I also happen to be an FNB client, people who know me, who know my name, they can just use my name to find the other details, my first and last name. Then they can get my account number and my PIN. Then they transfer the money